Okay, so let's go with our part 2 of our diesel engine construction. So as a recap on our part 1, we have here the bed plate, the A-frame, the cylinder block or engine block, and here we have the cylinder head. So these three main body parts of our diesel engine is connected by a stay-bolt. Okay, that's for the recap. Next, we'll go for the cylinder head, the topmost part of the engine. Here we have the cylinder head. So the cylinder head forms the top of the combustion chamber, seal the combustion chamber, transfer combustion forces to engine structure. So act as a platform to deploy starting air and fuel to the system, provide the passage of cooling water from the liner to the exhaust valve, contains the valves, the passageways for the fuel mixture to move in and out of the engine. Okay, so we will discuss one by one what are these parts of the cylinder head. So for a 4-stroke diesel engine, we have here the intake valve and the exhaust valve. So intake valve opens at the proper time to let in air inside the engine, or if your engine is a dual fuel engine, so sometimes they use gas fuel along with air that it will enter into the intake valve. So it depends on your engine design and structure. Okay, next we have the exhaust valve opens at the proper time to release the exhaust or the impurities made during or after the combustion. Okay, next we have the valve cover. So the valve cover protects the valve. The valve springs, keeps dirt out and lubricating oil in. So on top of the cylinder head there is a cover, so they call it as a valve cover. And then around the valve we have a spring, so that is what we call the valve spring. So the valve spring helps keep the valve shut, so it always pushes the valve up so that it will close the it will always keep the valve shut. So depending on the design, a valve spring may compromise 1 or 2 different springs, sometimes even 3. So the triple spring construction is mostly found on performance engines where a high level of reliability is required. Okay, next you have here the valve spring retainer. So the valve spring retainer, as its name suggests, the spring retainer is the part that helps to maintain the spring position. So it mounts on the spring stop end. The valve spring retainer is usually made from steel. And then we have here the retainer lock, so that this retainer will not move out. So the retainer lock is the part that lies between the spring retainer and the tip of the valve. So the pressure or force exerted by the springs helps to hold the lock in place and the components intact. And then inside our valve, we have the valve seal, so mounted the valve stem. So this is the valve stem. And just under the spring, so the valve seal prevents cylinder head leaks. It keeps oil from getting into the intake and exhaust passageways and ensures the proper working of these cylinder head parts. So as you can see, this is how it is installed. So first we have here the valve, and then you put a spring on the valve, and then we have a valve stem here, and then put the valve seal so that there will be no leakage in the valve. And then we have the retainer and then the retainer lock. So that's how it is arranged. Next we have the valve guide. So the valve guide simply guides the valve. So our metal pieces, usually iron or bronze, that position and allow for free movement of valves. So the guides are usually removable parts pressed into the cylinder head during installation, so this makes replacing them during cylinder head refurbishment easy. And then we have here the valve, so the part of the valve with the stem, the fillet, and the seat. So this is the seat is very important. So this part provides a seat that the valve makes contact with to form a seal. So together with the valve, the cylinder head valve seat prevents combustion gases from escaping until the valve opens. So seat valves are made from hardened iron alloy and forcefully driven into the cylinder head to create an airtight seam. And then our valve seat is also, we also grind it so that the surface will be will be airtight onto the cylinder head. Okay. So as you can see here, this is the construction. We have the valve here, we have the valve guide, the spring, the retainer lock, and the retainer and the lock inside. And then here we have the rocker arm. This one is the rocker arm. This one, rocker arm, and then we have a push rod that pushes the valve down, and then the spring will move up to always make a lock in position or closed position on our valves. So the push rod will open the valve with the guide spring and the valve lifter on this side. So what is the use of the rocker arm? So it transfers the motion of a push rod to the corresponding intake or exhaust valve. So if there will be motion here, going up, the push rod will push the rocker arm down, and then the rocker arm will push our valve open. So that's how it works. Next, we have the valve lifter on this side. So the valve lifter is the component that opens and closes a valve. So it is worked by the camshaft. So in an overhead cam cylinder head, the lifter pushes against the valve directly. So there will be no push rod if we will be using an overhead cam. So like this one. So the rocker arm is here, the valve lifter is here, and there is no more push rod. And this is the overhead cam. So the valve lifters are used on the intake and exhaust valves. So this is a cylinder head 4-stroke engine, a sample. So we have here the spring, the valve inside, the retainer, and the lock inside. We have here the rocker arm, and then at the back is the push rod. Okay, we also have on the cylinder head the valve rotator or rotocap. Some engines don't use a simple retainer. Instead, the retainer has a ball and a spring inside. So it rotates as the valve moves up and down. The valve also rotates slowly, depending on how it rotates. So it will also rotate slowly. So with the use of the valve rotator or rotocap. So the purpose of this one is that all of the residue that will stick in our valve seat will be removed during our rotating motion. So this is a very slow motion, but it also removes the dirt that will stick in our valve. Also in the cylinder head, we have here at the center, we have the fuel valve. So this one, fuel injector or fuel valve. So fuel enters here and then sprayed inside the combustion chamber to create combustion and power. And then on this side, we have here the starting air valve, in which a 30 bar pressure starting air enters here so that we can start the engine, or we can start our engine. Next, we have here the exhaust valve for 2-stroke engine. So this is our 2-stroke engine. So the removal of exhaust gas at the correct time for the set duration. So that is the use of our exhaust valve. Maintain efficient sealing when closed to prevent compression air and exhaust gas leakage. Transfer the gases to the manifold for further use. Okay. So what are the parts of our cylinder head on our 2-stroke engine? So we have here, and inside here is the exhaust valve. So there is no inlet valve on our 2-stroke engine because we are using inlet port in our liners, as you can remember. And then we have here the air starting valve. So 30 bar starting air pressure to create a starting motion of our engine. We have the cylinder head cover. The fuel valve here. So in this engine we have 1, 2, and 3 fuel valve. You can use 1, 2, or 3 depending on the situation. We have here the safety valve to prevent from overpressure. We have the exhaust valve inside, and then indicator valve. So what are the use of the indicator valve? First, it measures and monitors the cylinder pressure of diesel engine while the engine is running. So we can monitor the performance of our diesel engine using the indicator valve. So this is to analyze the condition of the engine. Also, it is used to relieve pressure in the cylinder and allow the turning of the engine before startup. So if we are turning the engine using the turning gear, so we should open the indicator valve so that we can check if there are leakage inside our combustion chamber. If ever there will be leakage of liquid like fuel, lube oil, or water, So we should never start the engine. Since liquid is incompressible, it may damage the engine if you forcefully start it. Okay. Next, we have the safety valve. So relieve, protect the cylinder against excessive pressure. Okay, so that's it for that cylinder head for our 4-stroke and 2-stroke diesel engine. So now we will go to the turbocharger and arrangement. Okay, turbocharger and arrangement. So as you can see, the red one is the turbocharger. So there are 2 turbochargers. So these are the turbochargers, the red one. And then on top is the exhaust manifold. And below we have here the charge air cooler. Two charge air cooler. Okay, so we will discuss it one by one. So turbocharger charge air system. So as when the engine starts running, it will create combustion, and then those combustion will create exhaust gas. So those exhaust gas will be the one entering on this side of the turbocharger, pushing these turbine blades, rotating the turbine blades, and then the exhaust gas will go to the funnel. While on the other side of the turbocharger, since it is connected into one shaft, so the other side also rotates, and then air enters into the compressor side of the turbocharger, entering through the charge air cooler and to inside the engine for combustion again. So the charge air system flows like this. Okay, since air enters into the charge air cooler, why do we have to cool down the air? So why do we have to cool it down? So the purpose of this one is to create high volume of air entering into our combustion chamber. So the higher the volume of air that will enter into the combustion chamber, the higher the power it will be created during combustion. So the higher the power, the better performance of the engine. So that's why we have to cool down the air before it enters the diesel engine. Okay, so what are the advantages of having a turbocharger? So first, to increase the power of the engine, to reduce the size of the engine and to fit into a limited space, to reduce the weight of the engine per horsepower developed. So the lighter the engine, the better for the ship, so that we can make or have more cargoes to be loaded on board. And then number 4 is to overcome the effect of high altitude. Okay, what are the 2 types of the turbocharger? The axial turbine, the radial turbine. So the axial turbine is the exhaust enters axially along the axis, while for a radial turbine, the exhaust enters radially into the turbine. So axial turbine, exhaust gas in and out of the turbine blade along the axis of the shaft. For a radial turbine, exhaust gas enters the turbine blades along the radial direction and leaves the turbine along the trailing edge of the blade. Okay, schematic diagram of our turbocharger system. First, the fresh air enters here, going into our compressor and to our charge air cooler, and then the water is removed in the charge air cooler, and air enters here into the scavenged space, going into the inlet ports, and then inside the combustion chamber, and then compressed, and then after compression there will be power, and then exhaust going here, and then going into the turbocharger, making the turbocharger rotate. Okay, so that's how it goes. And then if the turbocharger is not yet running, and then we want to start the engine, we can also use our auxiliary blower. So this one is a motor driven, electrically driven blower, so it will rotate if ever there is less pressure or no pressure in the turbocharger charge air system. So in here we have to remove the water, so that to prevent damage of the engine. How? So water in here, or water droplets, as you can see, these are droplets only, so not so many. So these are droplets only. So water droplets, if it enters into our liner, or into our here in our liner. So since our liner is lubricated by oil, if that water mixes into our lubrication of oil, so the lubrication will be damaged and it will cause damage also to our moving parts. The piston, uh, the piston rings and the liner will also be damaged if ever the lubrication is broken. So that's why in here we have to remove the water in our charged air. Okay, types of exhaust gas system we have here. First, we have the 2 poles, we have the 3 poles, we have the pulse converter, multi-pulse, modular pulse converter, and constant pressure. So this is the exhaust manifold, and this is the exhaust side of our turbocharger. So these are the turbocharger. So what can you say about this arrangement? Okay, the pulse type exhaust gas systems. So as you can see, this 1, 2, 3, 4, 5, this one are all pulse type. So the pulse type exhaust gas system usually have a narrow exhaust manifold, while for a constant pressure exhaust gas system, its exhaust manifold is not so narrow. So it's a bigger one, larger one. Okay, so what's the difference? So if the exhaust manifold is very narrow, so if ever there will be exhaust going out from one cylinder, so this narrow exhaust manifold will create will have an easier build-up of pressure to create pressure to rotate our turbocharger. Where for constant pressure, so this one has a bigger exhaust manifold, so it will take time for it to be if it takes time for it to create or build pressure inside this exhaust manifold. So our turbocharger will also run will not run will not run directly, or will not run easily. Okay, so on our pulse type, so easier buildup of exhaust pressure, easier starting of our turbocharger. On constant pressure, so the buildup of pressure is not that fast, so the turbocharger will not also run fast. So what is the difference? So for our 4-stroke engine, we usually depend on our turbocharger so that we can start directly the engine. So we need a narrow type or a pulse type exhaust gas system like this one. But for a 2-stroke engine, since the 2-stroke engine already have an auxiliary blower that it will give pressure into our scavenge space when during starting of the engine, so we does not depend on the air on our turbocharger upon startup. So we can use constant pressure. The constant pressure exhaust gas system is not that stressful. Okay, so it is not that stressful for our turbocharger since the pressure is constant. But for a pulse type converter, it is very stressful for the turbocharger because there is a pulse or a pressure build up directly given in the turbocharger upon startup. So in the long run, the constant pressure have a lesser stress for our turbocharger. Okay, next we have here the scavenge tank. So we have here the scavenge tank, and then we have an air cooler mist catcher. So in this part, water is removed from our charged air, and then after our air cooler mist catcher, there is a flap so that the air will enter into our scavenge trunk or scavenge manifold, but it will not go back into the air cooler mist catcher because this flap is a non-return. So it will open, and if there is pressure inside, so it will close. Also inside our scavenge trunk, we have the relief valves and the temperature probe. So this is the relief valve and our temperature probes, either manual or digital temperature sensors. And on this side of our scavenge trunk, here is the um, liner and the inlet port. So the air will enter into the inlet ports going into our liner and combustion chamber. So the scavenge trunk, this person is cleaning our scavenge trunk for inspection. So the scavenge trunk is where air enters and stays until an inlet port on the liner will open. Okay. Next we have here, so from turbocharger it will go to a scavenge air cooler. It will cool down the air, and then water in the air is removed in the water separator, and then air will go up going into the flap, and then the flap will open and then going into our scavenge trunk or scavenge port. Okay, next we have here the air blowers, auxiliary blowers. This one, auxiliary blowers. So if the turbocharger is not yet running, so air will the engine still needs air, so the auxiliary blowers will run since it has an electric motor. So it will run automatically to give pressure or air into our scavenge trunk if ever the turbocharger is not yet running. Okay, air blowers, sleeve blowers. We have here the exhaust gas manifold, the turbocharger. The washing plant. So we have washing plant for our turbocharger also to clean the turbine side and the compressor side. So on our compressor side, we usually use water cleaning. But on the turbine side, they usually use dry cleaning using walnuts at high pressure, so that since the exhaust or the turbine is high temperature, so water will create thermal shock into the turbocharger. But on some engines, they use water on the turbine side, but the engine is not at its full speed, or it is still in its idle speed. So at a certain temperature, they will be using it, but at when the engine is at full speed, they will not use water washing anymore on the turbine side. We have here the scavenge air cooler, the water separator. We have here the auxiliary blowers 1 and 2, crankcase safety, valves, scavenge air cooler, condensate water line, and the turning gear. So turning gear to rotate the engine before starting up. Okay, so that's it for our part 2 of our diesel construction.